Good morning. According to classification of signals, we have seen that periodic signal and aperiodic signal is also one of the most important and useful category, because most of the analysis part as far as in frequency domain is considered, it is associated with the periodic nature, because we have to take decision based on the classification whether it is periodic or aperiodic, that we need to apply tool like Fourier series or Fourier transform. So in many applications, real-time applications as well, if signal is taking a uniform periodic form, or if it is going to be a deterministic one, then it becomes easy to analyze as compared to a periodic signal. So in this small presentation, we will go through what do you mean by periodic signal and how to estimate its period. So for that, some examples also we will go through. Now, as far as periodic nature is considered, then in general, a signal is called periodic if it completes a pattern within a measurable time frame called a period, and then repeats that pattern over identical subsequent periods. So, like this, say for example, anything it may be, not necessarily very standard, something like a square or triangular or ramp or staircase kind of a structure, but it may be anything, or it may be a hybrid kind of a signal, not that it has to be a sinusoid or exponential or square or triangular like that. So it may be anything, like here some shape is present, so some sort of a parabolic and mixed structure. So this is periodic because it is repeating itself within a measurable time frame, and that measurable time frame includes the off time and on time of the respective, say, cycle. So for example, here it is shown that T0, capital T0 is a period of this particular signal. Now, as far as aperiodic is considered, it is aperiodic or non-periodic signal is that is one that changes constantly without exhibiting a pattern or cycle that repeats over time. So here you can see something different is happening in this portion, something different. Again here something different. Here it is different. So there is no such a pattern, or we can observe some portion and then we can say that yes, here it is repetition once again, and maybe it may be a long period, but it is not that. It is not. It has to be finite one and or a predictable one. But this is not happening in this case. It is a totally pattern where there is no interrelation, or we can't describe or define it so that it will whole will represent one cycle. It is not like that. So therefore, such signals are said to be aperiodic. We can theoretically say that it is a period where we have like infinite period, or we can say. So this is the case where, just a moment, I made one mistake that I am clearing. So continuous time signal in general, mathematically it is expressed as far as its periodic nature is considered like this. So it is x of t is equal to x of t plus n capital T. So that corresponds, this t corresponds fundamental period, and it may be one cycle, first cycle you are observing, second cycle, third cycle, like that, anything it may be. So in general, say for example, we are talking about x of t, say some standard signal as a cos omega t. We want to check whether it is periodic or not. Then we will write it as t plus nt is equal to a cos of omega into bracket t plus tn or nt, whatever. So therefore a cos omega t plus omega 2 pi, and it is nothing but a cos 2 pi, because whatever is this 2 pi, it is going to be 2 pi plus theta, so it is going to be theta, and therefore we can call that it is a periodic one. We can write its fundamental frequency. We can write it like in the form of angular frequency, omega is equal to 2 pi 0. So t0 is a fundamental period, and for the signal which is going to satisfy the condition. So it may be like this, or something like say sin t. We can have a graph, or we can draw it, and even by observing it we can make it as a periodic or not, we can identify. Then there are some, say for example, two signals are there. So here it may be one signal is x1t, another signal is x2t. Then it may be having something as m1t1, and here it may be having m2t2, like that. Then the fundamental period, we define it as m1t1 is equal to m2t2, which is equal to t0. So say for example, we have cos of t pi by 3 and sine of t pi by 4. Then what we will write is t1 is equal to 2 pi by 3, which is equal to 6. T2 is equal to 2 pi by 4, which is nothing but 8. Therefore, T1 by T2, that is ratio of these two periods, is 6 by 8. It is a rational number, meaning is that it should be a ratio of integers. So M1 and M2 both are integers, or T1 and T2 in that M1 T1 equal to M2 T2, like that if we express. And we can have the LCM as well, so that we will get a respective period. So like that also we can calculate. We will solve some examples. At that time you will better understand. Just I'm here with this small slideshow, I'm sharing some basic information. Same fashion you can have sum of periodic signals. So here this A and B are to be integers, that you have to remember. And then you can have 3 into 8 or 6 into 4, that is your LCM, and that is indicating the fundamental period. So this is the case. Then we have, so product it may be. So this way also you can have one signal is XAT, another signal is XBT. Say for example, sine of something. This is, in this case it is 7 pi by 24. Here it is cos of t pi by 24. So 7 pi and pi. Now the signal result, we know that trigonometric identity we can use. So here it is sine plus sine, sine minus sine, cos plus cos, cos minus cos, or sine into cos, cos into sine, or cos into cos, or sine into sine. So this way we can express, and we can obtain again the fundamental period. So here, instead of keeping it in multiplication form, you can convert it into addition form. So sine into cos, you can make it sine plus sine, and accordingly you can write the periods, and you can get fundamental period. So this is also possible. It is not always periodic one, though two periodic signals are added. So like here, say x1t plus x2t, which is cos t plus sine of root 2t. So for one case it is 2 pi by 1, that is 2 pi. So for first case, that is cos t. In the second case it is 2 pi by square root of 2. So t1 by t2 is square root of 2 is the ratio, and since square root of 2 is not a rational integer number, therefore it is, ratio is not rational, therefore it is irrational, and therefore this resultant signal is not periodic signal. So it is said to be a non-periodic or aperiodic. Then same fashion you can have number of signals, and even you can find out its fundamental period. So same fashion, but only thing is that you have to consider all the terms respectively. Say for example, here one signal is cos of 3.5t, second signal is sine of 2t, third signal is 2 cos of, say for example, t7 by 6, that is 7 by 6. Now fundamental frequencies we can write as 1 upon 1 upon, or in terms of omega 1, omega 2, omega 3 also we can write. Now first two, t1 by t2, if we consider here, then the ratio is coming 4 by 7. t1 by t3, it is coming 1 by 3. So here also ratio of two integers, here also ratio of two integers. So that's why resultant summation is periodic one. So here we can make, see here, t1, t2, t3, then m1, m3, and you can have the m1 t1 equal to m2 t2 is equal to m3 t3. So we can find that 7 t1 is equal to 4 t2 and 3 t1 is equal to 1 t3. So here what we can do is we can take the LCM, and the final period you can obtain. So t0 is 21 t1, and 21 into t1, one value you can take 2 pi by 3.5. So this first one, so 2 pi by 3.5. So resultant, which is equal to 12 t2. So like that we can take, and therefore it comes out to be 12 pi. So you can have any, okay, not necessarily here this way. It is for this particular, it is coming like 21 t1 is equal to 12 t2 is equal to 7 t3. So you can interrelate, and you can have a fundamental period in terms of LCM. we can take. So this way, these are some of the basics, like you have to remember addition and all. And let us have some examples so that you will better understand what exactly it is and how it is to be done. So this is first one. Sine of 2 pi n divided by 3 plus cos of 2 pi n divided by 5. We will solve it. So 2 pi f1 is equal to, in this case, you compare with standard expression sine omega 0 t. So this comes out to be 2 pi by 3. This n indicating discrete time. So 2 pi by 3. Now from this, 2 pi into f1 is equal to 2 pi by 3. So 2 pi will get cancelled. F1 is equal to 1 by 3. Therefore n1 is equal to 3. Same fashion, 2 pi f2 is equal to 2 pi by 5 for say second term. So f2 is equal to 1 upon 5 and therefore n2 is equal to 5. So discrete time I am considering. So we will consider some discrete time as well as continuous time. So at present I am taking example of discrete time. So here n2 is equal to 5. Now if you take the ratio of n1 upon n2 is equal to 3 by 5, or n2 by n1 also is allowed. So this is a ratio of two integers. So therefore it is fundamental period is its LCM. So 3 into 5. So it comes out to be 15. Second one we can take. So here x1 is equal to cos of pi by 2 plus 0.3 n. So here if we compare cos of 2 pi fn plus theta, therefore 2 pi fn is equal to 0.3. This one you can make it, and theta is equal to pi by 2. So this comes out to be f is equal to 0.3 divided by 2 pi. So that is nothing but 0.3 is 3 by 10. So that is 3 upon 20 pi. So since this pi is not taken as a rational number, this ratio, that is 3 upon 20 pi, is not rational. So therefore it is non-periodic. Let us have one more. So this is x of n is equal to 1 plus e raised to j2 pi n by 3 minus e raised to j4 pi by n by 7. So like that it is. So here x1 is equal to, DC signal arbitrary period is 1, this is 1 constant part. X2 is equal to j2 pi n by 3, and this next is j4 pi n by 7. So here by mistake just one dash is appearing. So this is resultant is, for x2 it is 2 pi n by 3, therefore 2 pi f2n, f2 is equal to 1 by 3. So this comes out to be k2 by n2, that is 1 upon 3. So that is n2 is equal to 3. And here it is, as far as third term is considered, so x3n, it comes out to be e raised to j2 pi f3n. So 2 pi f3n is equal to 4 pi n by 7. So we'll write 4 pi n by 7. So f3 is equal to 2 by 7, which is equal to k3 by f3. So that is n3. If we write in terms of period, it comes out to be reciprocal of this. So 7 by 2. Now n1 by n2 is equal to 1 by 3. So whatever we did here, n1 by n2 is equal to 1 by 3. That is a rational number. And n1 by n3 is equal to 1 upon, n3 is 7 by 2. So 1 upon 7 by 3. Because n1 is 1, that is our this first term. Just try to understand. This x1, DC arbitrary period is 1. This is n1, this is n2, and this is n3. And now we are taking ratio. So n1 by n2 is equal to 1 by 3. This is first one. n1 by n3 is equal to 1 upon 7 by 2. That is 2 by 7. This is also rational number. And then LCM of n1, n2 and n3 is equal to 7 by 2 into 1 into 3. So it comes out to be 21 by 2, which is 10.5. And this is fundamental period of this resultant signal. So our signal was including, this includes 3 terms, 1 e raised to j2 pi n by 3 and 4 pi n by 7. So this is third one. Now next one we will take, say for example, x of n is equal to cos of n by 6 cos of pi n by 6, n pi by 6. So first term, cos of 2 pi f1 n is equal to cos of n by 6. Therefore 2 pi f1 n is equal to n by 6. So n will get cancelled. Therefore 2 pi f1 is equal to 1 by 6, and therefore f1 is equal to 1 upon 12 pi. Okay, fine. Next one is cos of 2 pi f2n, which is equal to cos of n pi by 6. Therefore 2 pi f2n, this bracket 2 pi f2n is equal to n pi by 6. So n will get cancelled, pi will get cancelled. Therefore f2 is equal to 1 upon this 2 will come here in the denominator and it will become 1 upon 12. Now f1 is 1 upon 12 pi. Here it is pi is not a rational integer number, so therefore it is not rational. Ratio is not of integers, therefore it is not periodic. And second one, it is rational because it is 1 upon 12, but the product is not periodic because here we have done the product of one non-periodic and another one periodic, so resultant is non-periodic. Next one is x of t is equal to 3u of t plus 2 sin 2t. So here period of 3u of t is equal to 0 because u of t is having infinity. There is no repetition, so it is aperiodic. And 2 sin 2t is pi. So 2 times sin 2t is periodic with period pi, but sum is aperiodic because infinity plus something. So resultant signal will definitely be non-periodic or aperiodic. Now this is one more. X of t is equal to 6 into e raised to j 4t plus pi by 3 plus 8 into e raised to j into bracket 3 pi t plus pi by 4. Now first term we will take x1 is equal to this 6 into e raised to j into bracket 4t plus pi by 3. Now we will compare it with a into e raised to j omega 1 t plus theta. So omega 1 is equal to 4 here. Here you can have omega 1, and therefore 2 pi f1 is equal to 4. Therefore f1 is equal to 2 upon pi and t1 is equal to pi by 2. Fine. Now second term is 8 into e raised to j 3 pi t plus pi by 4. So this we will compare with b into e raised to j omega 2 plus theta 2. So from that omega 2 is equal to this first term we are taking 3 pi, this one 3 pi. So that is 2 pi f2 is equal to 3 pi. Same fashion. Here also we have considered this 4. So here we have considered this 3. So f2 is equal to 3 by 2 and therefore t2 is equal to 2 by 3, reciprocal of this frequency, that is period. So here it is 2 by pi, here reciprocal is pi by 2, here it is 3 by 2, reciprocal is 3 by 2, 2 by 3. And now ratio of t1 by t2 comes out to be pi by 2 divided by 2 by 3. 2 will get cancelled and it will be, it will not get cancelled. This 3 will come here in the numerator and resultant will be 3 pi by 4. Since pi is not integer, so therefore this resultant is not rational. Ratio of one is non-integer, numerator is non-integer, and therefore it is not periodic, but it is a periodic signal. Now see this one more simple one. U of t minus 2 into u of t minus 5. So u of t we will draw just one amplitude and it is 0 to infinity. Second one, u of t minus 5. T minus 5 means it will go 5 divisions minus 5. So it is shifting by 5 units. In which direction? Right direction. And this minus sign we will give to the amplitude and it will also get scaled by 2. Therefore, standard amplitude of u of t is 1. It is going to get multiplied by 2. So that's why it will become 2. But it is with minus sign. So therefore, this will come down. And now this minus this we are doing. Or rather here with minus sign, since we have considered, now simply you have to add it. So up to 5 this signal is existing, but up to 5 this signal is not there. Therefore this portion will appear as it is. So see here, this portion will appear up to 5, and after 5, since this is minus 2 and this is plus 1, so resultant will be minus 1 and it will continue minus 1 as it is up to infinity, and therefore the whole structure is not periodic, it is aperiodic. It is nowhere repeating itself in the defined time frame, so therefore it is aperiodic. One more we will take. So this is also simple one. Sine of 0.02 pi n. So 0.02 pi is equal to 2 pi f. So f is equal to 0.025 divided by 2 pi. 2 pi to pi will get cancelled. So it is remaining 0.01. So that is 1 upon 100. And this is k upon n. It is a rational ratio because k and n both are integers. Therefore, this signal is periodic one. So some examples with discrete time consideration we have done. So in one more session we will do it for some examples associated with continuous time. So this is periodic nature, and definitely estimation of fundamental period is very important for the analysis purpose. So these are some of the techniques with the help of them, with the help of which we can solve and find out the period. And a strategy we can apply when multiple signals are involved, that is 2 signals are added or 3 signals are added, or sometimes signals are multiplied. Then at that time also we can calculate the fundamental period. To summarize here, for the multiple signals, that is sum of 2 signals, fundamentally it's sum of 2 signals, most of the times you may have to go for. So there the ratio must come out to be rational, then only it is periodic, otherwise it is aperiodic. So please do remember, and when number of periods are involved, and at that time if you want to find out fundamental period or resultant period, then if you are not able to cancel or some adjustment mathematically you can't do, then better is to take LCM, and that LCM value will represent the fundamental period, because that harmonic definitely is representing the fundamental harmonic of that particular signal. So this is about periodicity associated with signals, and we have considered examples of discrete time. Thank you.